Welcome to Neuroscience Narratives, the podcast where we explore fascinating facts about the brain. I'm your host, Zara, and today we're joined by neurobiology researcher Dr. Jamal Hassan to discuss a common belief about alcohol and brain cells. Jamal, thanks for being here.
Thanks for having me, Zara. I'm excited to dive into this topic and separate fact from fiction.
Great, so let's get right to it. We've all heard the claim that drinking alcohol kills brain cells. Is there any truth to this popular notion?
That's an excellent question, Zara. The short answer is no. Alcohol does not directly kill brain cells in adults. This is actually one of the many myths about the brain that we often encounter. However, the relationship between alcohol and the brain is complex, and excessive alcohol consumption can certainly have negative effects on brain function.
Interesting. So if alcohol doesn't kill brain cells, what exactly does it do to our brains?
Well, alcohol primarily affects the communication between neurons. It interferes with the brain's neural pathways by altering neurotransmitter function. Specifically, alcohol enhances the effects of GABA, an inhibitory neurotransmitter, while suppressing glutamate, an excitatory neurotransmitter. This leads to the depressant effects we associate with alcohol consumption.
That's fascinating. So it's more about disrupting communication rather than destroying cells. But surely excessive drinking must have some long-term consequences, right?
Absolutely, Zara. While alcohol doesn't kill neurons directly, chronic heavy drinking can lead to brain damage through various mechanisms. For instance, it can cause thiamine deficiency, which is essential for brain function. Severe thiamine deficiency can lead to Wernicke-Korsakoff syndrome, causing confusion, memory problems, and even permanent brain damage.
That sounds serious. Are there other ways alcohol can impact brain structure or function over time?
Yes, there are. Chronic alcohol abuse can lead to shrinkage of brain tissue and disruption of white matter integrity. This can affect cognitive functions like memory, decision-making, and impulse control. Additionally, alcohol can indirectly contribute to brain cell death by increasing the risk of accidents, falls, and other traumas that can cause brain injury.
I see. So while it doesn't directly kill brain cells, the effects can still be quite detrimental. What about binge drinking? Does that have any specific impacts?
Binge drinking is indeed a concern, Zara. While it may not kill brain cells outright, it can cause blackouts by interfering with the brain's ability to form new memories. Repeated binge drinking can lead to cognitive deficits and increase the risk of developing alcohol use disorder.
That's important information for our listeners, especially university students who might engage in binge drinking. Are there any positive aspects to this research? For instance, can the brain recover from alcohol-related damage?
That's a great question. The brain does have remarkable plasticity and can often recover, at least partially, from alcohol-induced damage if a person stops drinking or significantly reduces their alcohol intake. Studies have shown improvements in brain volume and cognitive function after periods of abstinence. However, some changes may be long-lasting or permanent, especially in cases of severe, prolonged alcohol abuse.
That's encouraging to know that there's potential for recovery. Before we wrap up, Jamal, could you share any current research directions in this field?
Certainly. Current research is focusing on understanding the molecular mechanisms of how alcohol affects brain function. Scientists are also investigating potential therapies to mitigate alcohol-induced brain damage and exploring genetic factors that might influence susceptibility to alcohol's effects on the brain.
Fascinating stuff, Jamal. To summarize for our listeners, while alcohol doesn't directly kill brain cells as commonly believed, it can significantly disrupt brain function and potentially lead to brain damage through various mechanisms, especially with chronic heavy use.
That's an excellent summary, Zara. I'd just add that moderation is key. While occasional, moderate drinking isn't likely to cause significant brain issues in healthy adults, excessive or chronic alcohol use can indeed have serious neurological consequences.
Thank you, Dr. Jamal Hassan, for sharing your expertise with us today. And thank you, listeners, for tuning in to Neuroscience Narratives. Remember, when it comes to alcohol and brain health, it's not about cell death, but rather about maintaining healthy neural communication and overall brain function. Until next time, keep those neurons firing.